Hi everyone, this is going to be a video walkthrough for question 10b, and I'm going to be going over the second solution, which is a Dijkstra's post-processing. Okay, so what Dijkstra's post-processing means is that we first run Dijkstra's, and then we use the information of Dijkstra's to help us solve the problem, right? So naturally, the first question I have for all of you guys watching is how can we use the information of Dijkstra's to help us find the valid goal peaks? Okay, and what is the information of Dijkstra's? Recall there's two things we get out of Dijkstra's. We get an edge 2, and we get a distance 2. So using both of these two things, how can we determine if a peak is a valid goal peak? So pause the video if you guys haven't had a chance to think about that already. So getting back to this question, let's look at C. So if S is the start, we know from like the previous examples is that C is a valid goal peak, okay? How can we determine that C is a valid goal peak if we have the edge 2 and the distance 2 arrays, okay? Well, let's try to figure it out. The distance to C will be 10. The edge to C will be B, okay? And we know that for C to be a valid goal peak, there must be two shortest paths that differ in the last edge, right? Well, after running Dijkstra's, we know that the first shortest path to get to C is of weight 10, and it goes through B. So all we really need to ask ourselves, is there another shortest path to get to C that's also of weight 10, but that doesn't go through B, right? So I'll repeat that down here. All we need to ask is there another shortest path to get to C that doesn't go through B? Okay, so what we can do, which I think is very intuitive, is that we will iterate through all of the neighbors of C, okay? In this case, C only has one neighbor, and we're going to ask ourselves the question, is there a shortest path via the neighbor to get to C, okay? So let's kind of like start translating this into code as we're going. So the first thing we're going to do is run Dijkstra's. Okay, and recall the reason for this is to get the edge 2 and distance 2 populated. Okay, the second thing that we're trying to do is figure out the valid goal peaks. Okay, to figure out the valid goal peaks, we're going to iterate through each peak in the graph. Okay, so now we're trying to figure out if this peak is a valid goal peak. For this peak to be a valid goal peak, that means it has two shortest paths that differ in the last edge. Okay, so what we'll do is we'll iterate for each neighbor in neighbors of the peak. Okay, this is a bit big, so I'm gonna make it a bit smaller. Except the edge 2. Okay, so what we're doing here is that we're iterating through all the possible neighbors that we can get to C with a new shortest path that we haven't discovered yet. Okay, so I'll write that right there. So we are looking for another shortest path to get to the peak. In this case, when we're at C, we're looking at all of our neighbors and asking ourselves, is it possible for me to get to C via this neighbor. And that path via this neighbor should be a shortest path, right? And what does it mean to be a shortest path? It must be of the same cost as the shortest path that we recorded in the distance to. Okay, so we'll add that check here. So if the distance to the neighbor plus the edge between the neighbor and the peak is equal to the distance to the peak, right? What this is saying is that this is the distance to the neighbor, right? The distance to the neighbor is the shortest recorded distance to get to that neighbor, plus this edge. If that is equal to the distance to the peak, that means we have found a different shortest path to get to the peak, right? Which is exactly what the valid goal peak problem is trying to solve. So what we can say is that we have found another goal peak, okay? But we don't know if the goal peak that we have found is better than the optimal peak that we recorded so far, okay? So what I'm going to do is, okay, I forgot one thing, is that we need to create an optimal peak variable, and we'll set that equal to null. Okay, and the optimal peak variable is going to be the best valid goal peak we've seen so far. So if we enter this if condition, it means, let me add my purple explanation, that peak is a valid goal peak. Okay, that's what happens if we enter this if condition. So the next if condition we should ask ourselves, is the peak the optimal peak, right? So for something to be the optimal peak, it must be farther away than the previously recorded optimal peak. So we'll ask ourselves if the distance to peak is strictly greater, it doesn't have to be strictly, but it doesn't matter how we break ties, the distance to the optimal peak, okay? And then we should also add in like a null check, but that's totally fine. Then what we'll do is set the optimal peak equal to peak. Okay, and that's saying that, actually this if condition is checking if something is a valid goal peak, and this one is saying that the peak is a better valid goal peak than the previously recorded one. Okay, so just a quick recap of what we've done so far, and this is actually the solution, so just a quick recap of the solution, is that we're first going to run Dijkstra's, and we're going to use the information from Dijkstra's, specifically the distance to and edge to help us solve the problem. Now what we're going to do is iterate through each peak in the graph, and we're going to ask ourselves, is this peak a valid goal peak? For a peak to be a valid goal peak, there must be two shortest paths that get to it that differ in the last edge, okay? So what we're going to do is we're going to look at all of the neighbors that aren't the neighbor we took to get to the peak, okay? And we're going to ask ourselves, is there a new neighbor I can take to get to that peak that is a shortest path, right? That's what this check is doing right here. And then finally, we ask ourselves, now that I have a valid goal peak, is it better than the previously recorded optimal peak? And if so, we update. So that is all for the Dijkstra's post-processing solution. I hope you guys enjoyed this problem. I think it's really cool. And yeah, good luck.